Dear listeners and viewers, it is my pleasure to welcome you all to yet another edition of Takehome webinar series. It is another edition in our series of webinars in the run-up to the finals and award ceremony of the 2021 National Life Sciences Competition. And we have Omowunmi Agboola Sadik. Hi, Prof. You're welcome.
Thank you. Thank you very much for having me.
And to know a bit more about Prof, she is a distinguished professor and chair at the Department of Chemistry and Environmental Science at the New Jersey Institute of Technology. Until August 2019, she was a professor of chemistry and director of the Center for Research in Advanced Sensing Technologies and Environmental Sustainability at the State University of New York at Binghamton. Professor Sadik received her bachelor's and master's degree in chemistry from the University of Lagos in 1985 and 87 respectively. And after working briefly as a high school chemistry teacher, she joined the Nigerian Institute of Oceanography and Marine Research in Victoria Island, Lagos, as a research scientist, and this she did for 2 years. So she then won the Australian International Development Agency Bureau Merit Scholar Award, which is a full scholarship from the University of Australia. And with this, she pursued her PhD in chemistry. She bagged her PhD in 1994 from the University of Wollongong in Australia. And she was awarded a United States National Research Council postdoctoral fellowship, which she completed at the United States Environmental Protection Agency in Las Vegas, Nevada, United States. Thereafter, she joined the State University of New York at Binghamton as an assistant professor of chemistry in September 1996. She became an associate prof in 2002 and a full prof in 2005 before leaving for her current role as distinguished professor and chair of the Department of Chemistry and Environmental Science at the New Jersey Institute of Technology. She has held several appointments at Harvard University, Cornell University, and the Naval Research Laboratory. Her research areas include surface chemistry, sensors, energy, and the environment, along with new measurement approaches and her application to solving problems in biological systems. Professor Sadik holds US patents, 5 of them, and has been recognized for research innovation in biosensors and sustainable nanotechnology. Her research areas include surface chemistry, chemical and biological sensors, new measurement approaches and their applications to real-life problems in biological systems, energy, and the environment. She holds 5 United States patents, and some of these have been licensed for commercial uses. Applications for additional 7 United States patents have also been filed and are pending review from her. So her inventions have helped drive changes in many years, including chemistry, pain management, tourism. She has had a lot of contributions, and her work was named by the Chronicles of Higher Education in the United States as one of 10 research projects across the world which could keep society safer. So you wouldn't be surprised that we have her discussing with us today science, technology, and innovation as catalysts for sustainable development. So she has pioneered a new detection platform as metal enhanced electrochemical detection. Many of these we may be finding in her presentation as you tag along. So she has secured over 7 million US dollars research grants from the United States government agencies and private sector institutions such as the United States National Science Foundation, the United States Environmental Protection Agency, the United States Department of Defense, and others, including the Bill and Melinda Gates Foundation. Professor Sadik is our distinguished guest of today, And she's specially on board today because she's also a sponsor of one of our awards, particularly the Professor Omowunmi Agboola Sadik Prize on Innovation. Ladies and gentlemen, I hope we all are glad to have Professor Sadik join us today, and we thank her very much for finding time out of her day. She had to wake up very early this morning. It's 8 o'clock in the US now, and just because she wants to give us this talk. We thank you very much, Prof, for joining us, and you have the floor to start your presentation. Thank you.
Thank you very much for having me. Can you hear me? Can you hear me?
Yes, your slides
Very
visible.
good. Very good. Okay, so let me try to thank you for that introduction. And first want to say how impressed and inspired you guys have been, at the SCI, for your organization, as well as the, just what you're doing to encourage the next generation into science and technology. This is a great work you're doing, and I just want to applaud you. And so let me start by, you've heard about my journey, and so I will not spend the time very much to go over that. The goal of my presentation today is to give you a sense of where science, technology, and innovation is, with a focus to Nigeria and the African continent, as well as how science, technology, and innovation can can be used as a catalyst for sustainable development. And so I'm going to advance my slide and give you a little background on, the status of STI. So when I say STI, you know exactly what I'm talking about: science, technology, and innovation. So Nigeria is the most populous nation in Africa, and it's also the largest economy in Africa. And by 2050, it has been predicted that Nigeria will be the third most populous country in the world, behind China and India. With Nigeria's GDP of over 400 billion US dollars, Nigeria has the largest economy, and I believe followed by South Africa. So the population, if you want to look at population, could be a great advantage. It can also be a disadvantage if it's not managed properly. So Nigeria, another uniqueness about Nigeria's population is that it has a very young population, unlike what we see in Europe, with aging population in other parts of the world. And so the nation has a lot of advantage to harness this young population for science, technology, and innovation. And when we talk about science, technology, and innovation, we're talking about economy, really. We're talking about livelihood. We're talking about how we can take scientific endeavor, the scientific enterprise, and making it work for us economically. And if you look at the Nigerian economy, for the most part, we are dependent on, on crude oil. But in the last few years, there's been a lot of diversification. Agriculture is about 40% of the sector, contributing to the GDP. There are other emerging areas as well, like the Nollywood. Believe it or not, the Nollywood is getting a big chunk of the economy. So, science, technology, and innovation is linked to the economy. And what I want to talk about is how Nigeria can actually broaden its economic base, and the significance of science, technology, and innovation as a catalyst for the economy. Typically when we talk about the academia, it's never been about creating companies or but it's always about advancing knowledge for the sake of knowledge's sake. Yet, If you look at the biggest economies in the world, if you focus on America's academic institutions, they've had a very strong hand in building the technology boom that surrounds it today. And what do I mean by that? If you take a look at, the major 10 top companies in the world, coming out of Stanford and the Silicon Valley in California, these are mainly actually they started from universities. And so you have to think about the role of the universities in our economic development. And so these are the things I'm going to talk about today. I will just give you a very quick overview of where we are as far as STI in Nigeria and what sustainable development is and how we can harness it. In a way, I will touch on a little bit on some of the things that we've done in our lab, even though I won't spend much time there. But finally, I'm going to give us a roadmap. It just one a roadmap. There are many ways, but that's a roadmap for achieving sustainable development in Nigeria using science, technology, and innovation. Can you see my slides that I'm advancing? Okay, I assume it is. So in Stanford, these are the top, most, the top companies in the world. And Apple, you think about Google, Facebook, Cisco, and Netflix. All of these companies actually um, came out of Stanford, faculty and students, and they're shaping the revolution hub in Silicon Valley and around the world. And so science, technology, and innovation is key. And I'm going to define it. When we talk about science, what do we mean? Is the creation of knowledge. We understand how electronics work, how gravity works, the law of gravity, the law of nature. And we use that to create new knowledge for knowledge sake. Maybe that when you do science, you may not think about the immediate application of science. But then when you now take that further to look at technology, technology is the application of knowledge that you've developed using scientific principles. For example, you develop smartphones, computers, and all of that. But innovation is different from science or technology because innovation is the application of technology. For example, mobile banking, we know how big and ubiquitous that is now in Nigeria and in African economy as a whole. So innovation is critical. Innovation is key to sustainable development. Innovation is key to the economic development of any nation. When we talk about innovation, there is always a path towards it. And who are the people involved in innovative ideas? At the tertiary education institute, mostly that's where you start with the fundamental research, usually aim to improve scientific theories, to improve understanding. When you do applied research, you might want to go to some of the national labs like the Federal Institute of Research, show the FIRO or, NEOMA, Marine Research. But industry, so in terms of the technology development, you are really looking at some of these national labs. But when you now want to talk about the economy, it needs to be transferred into the industry. It needs the industrial money makers, the entrepreneurs must be involved. And so everybody is involved. Where the tertiary institutions are based on the fundamental research and applied research, the national labs are looking at the technology developments, and then the implementation. Usually, you have to have the Googles of the world. You have to have the companies to actually take this, beyond there. So, why do we need to promote science, technology, and innovation? So, typically, you know, it is important because it is the key to productivity in any economy. In the last 50 years, at least half of the US productivity can be accounted for the technological innovation that we see. Today we enjoy the fruits of innovation every day in our lives. We have all the things like cell phones, communication devices, we have the internet, we have the lasers, we have all of these internets that's actually tied us together. It makes the whole world very, very small village. These advances have generated millions of high skilled, high wage work, and they've significantly improved not only the lives of Americans, but also also around the world. Look at what is happening now in Asia. So in the 20th century, there was so many inventions that we thought they were degraded, like the nuclear power, okay, airplanes, the rockets, the submarines, antibiotics, and all of that. But in the 21st century, inventions are different. The 21st century inventions are those are the wearables. You have your phone, your iPhone. You have the robotics. You have flexible electronics, band like wireless electronics infused into polymers, so that researchers are doing a lot of work and taking technology beyond. It's not. TV is no longer innovation. It's been around. Airplanes is no longer innovation. But in the 21st century, we're talking about new innovation ideas. Can you imagine how powering your phone with your own body? Imagine that you are generating enough bacteria that will convert this energy, that will take glucose or sweat or sugars into energy, electrical energy, and then use that electrical energy to drive your phone, to drive your wristwatch. Imagine that all of those things are actually and can be harnessed within science, technology, and innovation. Okay, so here's the time for trivia. Who invented Google? We know Google is headquarters in San Francisco. The Google search engine handles roughly 70% of all online requests in the world, not just only in the US. They have the cloud services, the hardware, the software, they have the payment solutions, and all of that. They does everything, almost everything. So where did it start? He got started in 1998, actually, fairly late. If you consider this to the top 10 current technology leaders. For example, the Microsoft and Apple formed in the mid 1960s, and IBM way back in 1911. And in fact, IBM started from Binghamton, Endicott, in New York, where I was for over 2 decades. So everything at Google started when Larry Page, a graduate student from the University of Michigan, enrolled in Stanford University's PhD program for computer science. Page wrote his doctoral thesis on the World Wide Web, WWW. And at the time he wrote this, the web was not even what we know it to be today. It was just an idea in the minds of the world's top computer scientists at the time. It was a thesis. It was just a PhD thesis that he wrote. And the initial page rank algorithm formed the basis for Google. And on the 9th of January 1998, Larry Page and Sergey Brin, the other student working with him, filed a patent with the US PTO office for a method of node ranking in a linked database. One thing that is interesting to note is that they filed this patent under Stanford University. So Page and Brin licensed the use of this algorithm for their commercial endeavor from the school. And on September 4th of that same year, Google was officially founded. Officially founded. It was just an idea. Specifically, in his thesis, Page wondered if you could link, if you create links between pages to determine which page was more important. That was the idea. And from there, he created the theory that it would be possible to develop an algorithm that automatically did this. And if you know anything about Google search engine, how it works, you know that this was the beginnings of Google. So Page spent years working on his thesis project. It was proven to be quite challenging because of the mathematics involved. And what did he do? He reached out to another student at the university to help him refine the math. And between the two of them, they named the algorithm PageRank. And then they integrated the algorithm into a rudimentary search engine, and it set it on its way to start trolling the web. That was how the World Wide Web started. That was Google's evolution. And over the years, Google has evolved from a search centric company to a more than overarching technology with a large search division. They give us things like Gmails. Almost all the emails now are Gmails, even though they come on different names. They have AdWords and AdSense the Google Pixel. So at the end of the day, who invented Google? Larry Page and Sergey Brin. And however, the answer to who created many of the Google modern products is much, much more complex. And so the idea started from the university. Ideas started from simple algorithms, simple hypotheses, simple questions that we can ask and then proceed to answer. How does that link to Nigeria's economy? What is the relationship to what I want to talk to you about? As I said earlier, Nigeria's economy is the number one in Africa. We have a very young population. We have a large consumer market. There is a growing emerging capital market. And so even the GDP has not factored into other major sectors. For example, the Nollywood. The Nollywood is now what 1.4% of GDP. There's a lot of room to grow. And so academic ranking, unfortunately, doesn't match this giant in terms of the economy. Our academic ranking is, if you look at Nigeria rank 127th out of 139 countries in the 2011 Global Competitiveness Report, and had none of its universities among the top 500 in the world. Why? Because we don't pay a lot of attention to research and development. The R&D allocation is very, very minuscule compared to to the GDP. There's practically no focus on science, technology, and innovation. And we have this unwholesome dependence on crude oil. And so that is why the global competitiveness is unexpectedly low. And that can change. That can change if we pay attention to research and funding. Because all of the technologies that we all enjoy came out of the universities. And as long as there's a weak link between education, research, and commercialization sector, we are not going to be able to take them forward. Infrastructure is needed to support innovation. We need the expertise. We need science and technology. That is why what you guys are doing at the NLSC is key. And that's the most reason why we need to have the attention of the powers that be. There has to be cooperation. There has to be cooperation, even beyond Nigeria. African ownership, accountability, sustainability. And so we can also learn from other emerging economies because you can think, well, you're comparing us to America. America is far advanced. Okay, let's look at South Korea. South Korea research and development allocation is 52.7 billion as of 2011. And science, technology, and innovation is growing at a rapid one. It used to be one of the poorest countries, in the world. But now South Korea is number 24 on the 2011-2012 Global Competitive Index, number 14 in scientific publication, and it has 1.6% of the world's top 500 universities. What about China? China is 174.9 billion on R&D, and that's about 13.1% of the world's expenditure. China is the industrial powerhouse of the world. It uses science and technology to leverage its economy. What about others? We can look at Mozambique. Mozambique spends 0.5% of its GDP on science and technology. Mauritius, 0.4%. Uganda, 0.4%. Botswana, 0.5%. So we can do better. We can do better. And so I would say, even before we talk about some solutions, some roadmap, let's define sustainable development. The World Commission on the Environment and Development report that was published in 1987 is commonly known as the Brundtland Report, defined sustainable development as the development that meets the needs of the present without compromising the ability of the future generations to meet their own needs. And so we're meeting today's need, but we should not. We should also think about the future. And when we talk about sustainable development, there's always three legs to this story. There is the economy, there is the environment, and there is the society. The economy must grow. It will not it should not grow at the expense of destroying the environment, because then there's nothing left for the future generation to have. And then there's the society. The society must be carried along with it. And so when we talk about sustainable development, the United Nations Sustainable Development Program came up with the 17 SDP goals. And I cannot go through all of them, but I'm just going to highlight just the key ones that would certainly uh, uh, touch on STI, sustainability, science, technology, and innovation. If you look at the top 10 problems, top 10 humanity problems for the next 50 years, this was actually put together by Richard Smalley of Rice University in 2003. It's passed on now. He gave us these top 10 problems humanity. Number one is energy. Today, energy and gas is a major, economy problem in the world. Is what is causing a lot of angst that we're seeing recently. What about disease? COVID-19. We don't know what's coming next in the next, the last 2.5 years, the last 2 years, we've been battling, a viral disease. We don't know the ongoing health care long-term effect of COVID-19 on the health of the population. And so population is a good thing if it's well controlled. If it's well controlled. So I want to focus only on maybe two of the SDP goals. Goal 9, industries, innovation, and infrastructure. According to the United Nations Sustainable Development Goals, goal number 9 says we should build resilient infrastructure. We should promote sustainable industrialization and foster innovation. Right now, there are 3.8 billion people that do not have access to internet. And industry matters. Innovation is important, and infrastructure is key for the economy to grow, for the sustainable development of the economy. And the other one I'm going to point out is goal number 7. Goal number 7, according to the UN SDP, is affordable and clean energy. They're saying that we need to ensure access to affordable, reliable, sustainable, and modern energy for all. Affordable. Can we say that? Can we say that by 2020 we can ensure universal access to energy? I'm pleased to see what's happening in Ethiopia with this dam that they just beginning to work on, because energy is getting to be, it will continually be key issues for the world, because energy keeps the world running. Okay. And so the role of science, technology, and innovation to as a catalyst for economic development is very important. And I'm going to briefly touch on nanotechnology. Nanotechnology. So when we talk about nanotechnology, most people now know what it means. But what it is, what is it? Nanotechnology refers to technologies that are developed out of very tiny materials. When we look at materials in the physical world and we look at the size of things, a tennis ball, for example, would be like 10 meters or 10, minus 1, raised to 1 meters. But water molecule, very tiny, is about 10 to negative 10. Now, things like bacteria, things like viruses, we cannot visualize, right? But they're there. This is the limit of what human eye can see. Anything else, anything in this region beyond here, we can see. This is the tiny period on a paper. We can see that. But anything beyond this, in this regime, we cannot see. And so when we talk about nanomaterials, they fall within the range that we cannot see. But it used to be that as small, when things get very small, when we get between 1 to few nanometers, the law of quantum physics begin to fade. Because essentially what then happens is that they begin to create, they have unique properties, unique electronic properties, unique mechanical properties, unique uh, scientific size regime. That is what nanotechnology is. But is it new? Well, if you take a look at the ancient stained glasses in those cathedrals that we go to Europe to see, those ancient people knew that by putting varying amounts of tiny gold and silver in the glass, they could produce different colors. They will have red, they will have yellow, they will have blue, they will have green. They create different colors. That is not, those are the first nanotechnologies. The only difference is that they didn't have the technology to be able to view them. Today, we can create, if you take gold, for example, gold is malleable and ductile, is the noble metal, it doesn't fade, it has a very, very stable characteristic. It's always yellow in its purest form. But at the nano, everything is changed. At the nanoscale, you realize that gold can have all of these different colors. It can be ruby red, it can be nice, greenish yellow, it can be blue, depending on the size. That is nanomaterials. Because at the nanoscale, gold is no longer that yellow color that we see. It's all of these different colors. Not only that, it would have fluorescent properties. It will shine on the dark. Gold never, ordinary macroscopic gold wouldn't do that. So that's what is happening at the nanoscale. And at the nanoscale, all of this fundamental understanding that we have of nano at the classical physics materials level, catalytic properties are changing, thermal properties are changing, mechanical properties are changing. We now use this in different applications. For example, for solar panels. At the solar panels, you have all of these nanomaterials that have been infused around these flexible materials. We can use them in gas turbines, we can use them in energy generation, and in our own lab. We've done a lot of inventions, just as you've heard, and I won't spend a lot of time on this. We're developing green bio batteries where we're using hybrid polymers and paper to create very small amount of energy, green energy with very little carbon footprint. We're using light as a means to for bacteria to chew on any waste material, and the waste materials can now be turned into energy. So the bacteria will use this as food. So you can actually generate a lot of energy from waste. You just need to find ways to harness it to create high performance energy. It may not be a lot of energy that would power your home, but it can at least drive all of the smaller electronics that we carry along. And that is a good invention there. Another invention that we've seen in our group is called the UPAC, Ultra Portable Capillary Biosensor. This was developed, funded by the Department of Defense, and where we use this to look at, viruses and bacteria and many things like that. One green plastic that came out of our group is some of these polymers here. It is not only literally green. The apple in this bag stayed for 18 months without getting degraded. It's because of the anti uh, bacterial properties that we've infused on these polymers to make them. These have been patented, for food packaging to help our food retain its uniqueness. We have a whole list of all these different polymers, the different colors that we've developed in our group. And um, many of these are using nanotechnology and nanomaterials. The nanomaterials with different shapes, triangular, hexagonal, cylindrical, cuboidal, and they have different colors. Guess how we're making this? From apples and oranges and onions, because we're using flavonoids that are derived from all of these natural polymers to make all these nanoparticles. They're grained particles. We're not using, what we'll probably consider toxic in terms of volatile organics, but we're using naturally developing materials. So the focus is not on us. Let's go back to the roadmap. So I told you I'm going to do that in my conclusion. A roadmap for increasing scientific and technological innovations in Nigeria. What can we do? There's pathways. That is the pathway to sustainable future. Is to recognize the importance of research and development. Research and development is key to promote science, technology, and innovation. Encourage integration between the universities and the national labs. I don't know. I was a product of the University of Lagos, and I also was fortunate to work at the Nigerian Institute for Oceanography and Marine Research. I had a lot of experience doing research before even leaving Nigeria. I wonder if there's any correlation, if there's any communication even between the universities and the national labs. I wonder if FIRO has communications with some of the universities in Lagos or in its environs. But we need to have that communication. We need to be able to liaise between them. We need to promote investment of science, technology, and innovation in, bring them into the economy. Some of the technology hubs that we're beginning to see. There's a promising development right now that's going on in Nigeria. There's the technology hubs in Nigeria going on, which I'm very pleased to note will eventually become the catalyst for economic development. There are cities across the globe now that are creating their own Silicon Valley. They're choosing their own spin off names, such as Silicon Wadi in Tel Aviv in Israel, Santiago's Silicon Valley, Germany's Silicon Alley in Berlin. And what about in Nigeria? We have the technology hub. What about the our CCC, the co-creation hub in Yaba? And I believe this is the picture of this. We have the Stonebrick hub in Abuja. Nigeria is at the beginning of this technological renaissance, and we need to continue to promote this. We have the young population to do this. So the technology, the formula for technological innovation is straightforward. Government funding is key. All of this research and development has been funded from the US by US government. All of the different agencies in the US government. Government's involvement in funding most in research and development is key. Then there's the commercialization of these technologies by private sector. There has to be this public-private partnership in order for this to work. Much of the economic growth of the past 100 years directly resulted from technological development in computers, in cell phones, internets. We need to not just be consumers of these technologies. We can be developers. We can look at our environment and say, what are the needs? What are the challenges that we have? And what can we use? How can we use the things around us to solve the problems that we have? How can we, begin to develop our own vaccines? We have a lot of, we have microbiologists in the country. Do we have to always be on the begging and begathon and ask people to support us? We have the brains, we have the young population to help us. And what we need is involvement in the funding of the government to help us. And so I am going to conclude. I'm going to conclude. Here's a roadmap. Here's a roadmap. The first is the educational reforms. We need to integrate university missions so that there is incentive for research, there's incentive for teaching. It's not just for teaching, but only teach research and teaching. There has to be community outreach between the universities and the local communities. We need to go out there and find out what are the problems and how can we use our knowledge to solve the problems. There's got to be entrepreneurship. When there's money to be made, there are people that are going to make it. When we've created the knowledge can be transferred into real applications, real hard application for people's lives. And there's also the need for the regional and the national centers. All of the national labs, there has to be the communication between national labs and the universities, and we can select the best practice, the best technology for potential innovation and development. We need to strengthen those partnerships. The private public partnership needs to be strengthened. The diaspora is another area that is not being utilized. The diaspora is doing so much out of the country. We can use a lot of the diaspora. We can utilize some of the knowledge out there. Nigerians are the most educated in the US. You can look at the statistics, but there can be a lot of that. That's a big resources that can be used there. You know, and we can think about how to adopt and adapt technology, existing technology, solve local problems. Internships, there can be internships in university, there can be internships in industrial labs, there can be internships in companies. There has to be that communication, and of course funding is key. Funding is key. Right now we have 1% of GDP in science, and I'm not even sure how many of those are going to research at all. It's probably mainly being used to pay salaries. And so there has to be all of this, and we can't just do one thing. We have to harness all of this together. We need to strengthen the partnership. So I think with what I've said, I think you have been able to see, essentially what science and technology is, what science, technology, innovation is, the role of science, technology, and innovation in economy, where we are in terms of our funding level is very, very low. But research, science, technology, and innovation is key to economic development. There's money to be made, and it is there in knowledge. Knowledge created at the university level, being used at the local level to solve local problems, and in the involvement of all in addressing this. So when they ask the question, what does the future hold? It's always a very difficult thing to ask, when you talk about that, because you don't know what the future holds. But Thomas Watson Sr., chairman of the board at IBM in 1943, he said, I think there is a market for maybe 5 computers. We know how wrong he is. The Popular Mechanics magazine in 1949 was asked, computers in the future may weigh no more than 1.5 tons. We know how wrong they are. Ken Olsen, president and founder of Digital Equipment Corporation in 1977, he said this word. There's no reason anyone will want a computer in their homes. We know how wrong they are. Business editor for Prentice Hall, 1957. He said, I have traveled the length and breadth of this country and talked with the best people. And I can assure you that data processing is a fire that won't last out the year. We know how wrong he is. Engineer at the Advanced Computer Systems Lab at IBM in 1968, commenting on the microchip, what good it is for. Bill Gates of Microsoft wrote in his biography, even though you are on the right track, if you just stand there, you will get run over. We know he's right. We know he's right. So, what is my take home message? The take home message, the future lies in developing vocational and technological developments in the citizens. You go about and look at things. In fact, you go to hotels in Nigeria and you look at the steps. The staircases are so rugged. It's like we need people that knows how to do carpentry, masonry, technology. We have delegated the technology schools, all of the Yaba techs of the world, and we think, oh, these are the people that would take the fundamental research in universities into technology. We need to be able to connect with them. We need to be able to promote research, identification and development, and execution of research. We need to be able to engage developing the research and develop new tools. An extension, even if you have to copy, whatever it is you have to do. Look at how reverse engineer some of those things. Develop the human capital. Develop the global awareness. We are not just the little dot in the on the globe. We're forced to be reckoned with, not just in our population, but in our youth, in the young population that we can enhance and use and take advantage of it and harness the power of science, technology, and innovation to create the path to be the next great continent, shaped by our era, shaped by our place and our environment. So I think my take home message is that research is key. Science, technology, and innovation is the journey to economic development. Knowledge economy requires science, technology, and innovation. Today, when you do sciences in Nigeria, you end up with teaching. That's all you can do. It should not be the case. That is the powerhouse of knowledge that can actually develop our economy. And so we need to have this economic reform to to include increasing science, technology, and innovation to be able to make us. I like to end with a quote from Kwame Nkrumah. He said, "We when he was they were starting the African Union. This was in 1963. We shall accumulate machinery and establish steel works, iron foundries, and factories. We shall link the various states of our continent with communications. We shall astound the world with our hydroelectric power. We shall drain marshes and swamps, clear infested areas, feed the nourished, and rid our people of parasites and disease. It is within the possibility of science and technology to make even the Sahara bloom into a vast field with verdant vegetation for agricultural and industrial development. Even then, in 1963, Kwame Nkrumah recognized the importance of science and technology. We need to wake up and rediscover the significance of science, technology, and innovation in economic and sustainable development. And I thank you for your attention, and I will be happy to answer any question you have.
It seems to me like the host Rehan is frozen.
We can't hear you. Is he trying to say something?
Yeah, he's supposed to continue with the
Hear
conversation.
me now?
He's back.
So, Prof, I was saying a big thank you for that wonderful presentation. A lot of people joining from different parts of the world are really sending their greetings.
Sorry, Dr. Rehan, your sound, your voice is echoing. Maybe there is another device close to you that is interfering. Thank you. Okay, I guess before Rehan finally sorts the issue, I could perhaps be able to take over. Thank you so much, Prof, for such an inspiring presentation. It's just wow, and hopefully this video will reach out to all the major stakeholders because it has so much in it about how to change the state of science in Nigeria, how to see the value in supporting science for the future of not just the country but the continent. Rohan, just let me know when you're back. I think there are a number of questions and comments that are out there. Maybe I'll just put the first one, which is that so this is a journalist, a Nigerian journalist. He asks whether it will be okay to have the PowerPoint presentation of your talk to properly prepare for his news report.
Oh, sure, no problems. Oh, we need to get the words out. Thank you.
Thank you so much, Prof. All right, I'm pretty sure he's there. So I did also ask my question. So since I'm here, I could just read my question. I was wondering, you raised this important point about the issue of collaboration. So within Nigerian, between different institutions, how can we inspire and encourage the collaborations between, say, the universities, industry, and other institutions in Nigeria? What do the key stakeholders need to do?
Um, the if you look at the most, in fact, even the federal, if there's any funding that's been established for research in the U.S., there's always the need. You're encouraged to have multidisciplinary, interdisciplinary. When we do science, we don't do science in silos. What do I mean by that? We don't do science, well, in some ways, the establishment of departments and colleges and fields means that knowledge is so ubiquitous. Everything is expanding and exploding. The way to ensure that we have this collaboration is when there are funding agencies or funds established. I know that we have the TED fund now in Nigeria. The funding agencies will ensure that uh, whatever has been funded must be collaborative. So they're saying if you want to get the fund, if you're going to be supported by this agency, your research, your proposal must be collaborative in nature. And so the funding agencies set the stone, set this the stage and the tone by insisting that research should not be held in silos. And so they encourage anyone who is interested in getting funded to speak to their neighbors. Go out there, talk to the next department, talk, in the language that you guys will understand, and look for unique problems that you like to solve and come together to solve this and propose ideas to solve this. So the first place we want to start is at the funding stage, But if there is no funding agency, if there's no money being put there, there's no need, there's no encouragement to do it. Our universities are doing excellent work of teaching, but we need to elevate
Mm,
knowledge beyond teaching. Um, when you teach, you're teaching what it's already known. You're teaching, you're recycling knowledge, and it's a good thing because you're developing and growing the next generation. However, when you do research, you are extending knowledge beyond what is known. You're looking for something that we don't know. You're looking for solutions. You're looking for questions. You're answering questions that's unknown, and you're doing research. And so we need to extend to go beyond teaching at our institutions and encourage research. And encourage them. Research is the highest form of intellectual pursuit, and so that is important. And how you get this started is the funding agencies. The government must insist that this funding is not only going to University of Lagos. You need to talk to FIRO, uh, you need to talk to Neoma. You need to talk to the next department and the next break down the silos and encourage collaboration. That's a long answer, but I think you get the point.
Thank you very much, Prof. Can you hear me now?
Yes, we can.
All right. So I was also saying a big thank you for that presentation, a very inspiring one. And we've had a lot of acknowledgements and thank you messages from a lot of our viewers who have joined from different parts of the world. So thank you, Mahmoud, for laying out those first couple of questions. So there is another one here that is okay. It's also from Mahmoud, and he's trying to know. Say, how were you able to delve into the areas of engineering to make pioneering innovations? What do we need to do to follow your footsteps, Prof?
Okay. Thank you so much. I just want to first say that my last name Sadik is not a Q. It's a K. It's Sadik K, not Sadik Q. So please correct
That's
that.
very well noted, Prof.
Thank you. So the question is, how were you able to delve into areas of engineering to make pioneering innovations? And what do we need to do to follow your footsteps? Thank you for that question. One of the questions, one of my motivations, when I chose to be, uh, my parents wanted me to be a medical doctor. My mother, in particular, she said, "Oh, if you can be a doctor." And I was actually going into pharmacy because I really like chemistry. But at that time, nobody was encouraging me to go into chemistry. The only person that encouraged me was my dad. My mom asked the question, "What would you do with chemistry?" And I didn't know much to be able to answer her question. And all I said was, because based on the little that I've learned, that well, chemistry is what helps us with all the petrochemicals that we have. I was explaining to her about kerosene, how we get kerosene from crude oil, we get the asphalt, we get other things from crude oil, and that Nigeria is a major producer of oil, and I can work in the NNPC. That was the only thing I can convince her that it can make money. So why did I get delve into it? Because of the basic question my mother asked me. And I've always asked myself, no matter how deep I go into any fundamental, I always ask the question, what can we do with this? What is the application of this? And so I like to ask the questions to look for ways to can solve human problems. And so I always ask, I've always worked with engineers, and even, we don't limit ourselves the way we think that, okay, chemistry must only be chemicals and molecules. But chemistry is the core of everything, of engineering, of materials, everything, molecules, everything start at the molecular level. And so, you have to think beyond, the the constraints that's been placed, by you, to you, on you, by the society, and ask questions. And so I would encourage you to go outside of the silos, think outside of the box, ask questions, and even talk to people. If there's money to be made, you have entrepreneurs. Look at how you can look around you, a- and ask the question: what are the problems that can be solved? What are the problems now that can be solved? And when you do that, there's enough problems around to see. And how can I use my knowledge to solve them? And don't limit yourself. The Googles of the world are there. You can Google and download anything now. It used to be that you have to go to the library to read everything. They're there on the line, on the web. The world is a village.
Hmm. Thank you very much for that answer, yet inspiring, and that I believe has spurred the thinking faculties of virtually every youth, really, to think of what questions you like to solve in order to better your environment in a sustainable fashion so it can get better developed. We have Chinwe Alaribe is asking here that, and she says hi, so, and she got the spelling right. Good to her. So, she's- yeah, and she's also saying hi, great Akokite.
Yeah,
I'm
great
sure
Akokite.
she's thanking you for the enlightening lecture, and she wants you to give a bit of mention on intellectual property as a wealth on its own, and how can it be harnessed in Nigeria and integrated into policy making. Over to you,
Thank you so
Prof.
much. Thank you so much for that question, Chinwe. This is the key question, um, because without the intellectual property protected, you cannot expand into wealth. And so, one of the first things you want to do is to protect your ideas, right? Um, and if you find a solution to a problem, in addition to maybe creating a device or a technology to address that, you need to protect it. You need to apply for patent. And some of the patent we have, I know that we have the patent protection also in Nigeria as well. And I know that this is a challenge because many times we have ideas and we develop things and people basically steal it. And it's always a continuous challenge. And so, but I would still encourage you to go ahead and protect your property, intellectual property. Make sure that you apply for patent. Make sure that you know, and it's not unusual for people to actually get U.S. patent to protect their ideas, even though it was developed somewhere in Africa or in China or in South Korea, Japan. They still come and get the U.S. Patent for it. So it's a small village now. So protect your ideas. Apply for patent.
Thank you very much, Prof. We have another question from one of our younger audience, and he is a potential awardee in this competition. He's asking, why is technology and innovation not so encouraged in Nigeria?
Encouraged in Nigeria. Hello? I think we're losing you there.
Did you get the question?
Yes, I'm reading the question now. I can see it. Alege Muiwa ask, why is
Yeah.
technology and innovation not so much encouraged in Nigeria? That's a good question. Um, if you look at our educational system, we place great emphasis on, oh, you have to be a doctor, you have to be a lawyer or an engineer. And there's nothing wrong with that. But we also need to realize that knowledge is far greater than being a doctor, an engineer, or a lawyer. Okay, there's
Yeah.
so vast human knowledge to be developed. And so, unless people understand that there is a benefit to any human endeavor, they cannot be encouraged. How many times do you hear people saying, your parents, parents want their children to be something. How many of us are going into maybe basketball until we begin to see Nigerians going to basketball and they're having a good life doing it? Then we say, oh,
Yeah.
perhaps there's a field there. Or you want to be, you go into drama and there's good life to it. So the more we see people using science and technology and they have good life and economic development, then they will be much more encouraged. And so you can't blame our forebears for knowing what they know because that's what they see. But the more this broadens out and people see that, oh, you can actually do chemistry and live a good life. Oh, really? Maybe I can do chemistry then. So, but generally we have not really encouraged because we can't see the benefit of it. And so it's not been very much encouraged. But I think that will change over time.
Thank you very much, Prof. I hope you can hear me.
Yes.
All right. So the next one is also from one of our younger audience, and it's Ebere Chukwu Isaiah Ajayi. And he's wondering how do we merge this little funding available with doing expansive research? So he wants you to shed more light on that.
Okay. Thank you, Ajayi. With little funding available, I think the previous question also linked it to policy. One of the things we can do is to encourage the private sector to uh, support research locally. Okay, the government takes the lead, creates some funding for research, but also encourage certain percentage of the private sector, certain percentage of their profit to be devoted to research. Um, and
Hmm.
if there is a policy, there's a government involvement in this, and they don't have to necessarily manage the money, but make this up, make create the platform where companies and even institutions, universities, national labs can go to companies and seek for funding and give the private sectors some tax break, if you like, for supporting research. We can expand the pot. We can expand the the money that's available for research, and we must manage it well because I know that's another issue there in terms of management. But to answer your question, the little funding available, the government set the stage. We connect with the private sector. There is the private-public partnership to make it work.
So how about from the individual researcher's perspective, Prof?
From the individual
Vis-a-vis
researcher,
little fund available?
yeah, the little funds available, we need to increase the fund. In fact, in this presentation, I was going to show a table that shows how much we're putting into research compared to other parts of Africa and other, developing economies. Right now, it's very, very small. In 2015, there was a conference, national conference held in Ethiopia, where African countries were encouraged to put certain percentage of their GDPs into research. In fact, there was, in another portion of this presentation that shows how much Nigeria should be putting into research, but I don't think we're even near that at all. So unless we take that step, most of the knowledge in the university will stay there. It will never be developed.
Hmm. Thank you very much, Prof. And this one says that this is more like commending things like people like you are doing and a number of other diasporans. So trying to give back to the country. So Munira Raji, wants you to say something a little more about how Nigerians in diaspora can help strengthen STI education in Nigeria.
Very good. Thank you, Munira. This is a very good question. How can Nigerian scientists in the diaspora help to strengthen science, technology, innovation, education in Nigeria? Um, The Nigerians in diaspora, for example, one way we can do that, you have this wealth of knowledge. For example, if you're in academia, summers, you can do research anywhere in the world. One way in that I have been involved is I've worked with uh, University of Lagos, my alma mater, to uh, seek funding. I have worked with South Africa, several universities, University of Western Cape in South Africa, University of Johannesburg, to uh, get funding for research. One of the examples that we've done is, pollution, the Nigerian waterways. They've created, some research going on there. So that's Nigerians in diaspora can help. They can come and spend a week or two and give lectures. They can donate. They can support scholarships. They can show by their examples that science, technology, and innovation is actually worth doing. We can encourage those who are doing sciences that it's not a dead end. It is actually the way to economic development. It is the pathway to entrepreneurship. It is the pathway to all of the technologies that you see, that you carry around you. Without science and fundamental science, you cannot see them. And so there has to be that connection and education. So science in people in diaspora, and they're doing a lot. I know a lot of people that go back, and they go back. I give lectures all over the world. I go to South Africa every time, other parts of Africa, in Nigeria. I've worked with Redeemers Run, Redeemers University of Technology. We've submitted proposals. So there's a lot that we can do. Give your, share your knowledge, expand the knowledge, help people in any way that you can. Give them, just the pathway to how you have been helped, and give back.
Thank you very much, Prof. Can you hear me?
Yes.
Yeah, so the next and probably one of the final questions is having to do with the female scientists. And I think it was for the sake of time that I couldn't get to that part of reading your bio, and I think it's very important. I mentioned this before I read the question. And this is for the audience to know that Professor Sadik, despite though born, I mean, she's born and raised in Lagos, Nigeria, she's married with 3 children, and she's married to engineer Abiodun Adewale Sadik, who I believe is and who is a medical doctor who first earned a bachelor's degree in chemistry, just like Professor Sadiq, and then a degree in medicine, both from the University of Pittsburgh. And thereafter, she completed her medical residency at Harvard University and her medical fellowship at Johns Hopkins University. The second of Professor Sadiq's wonderful children, who earned his bachelor's degree in finance from Maryland, his doctor of jurisprudence degree from Yale Law School, and his master of business administration degree from Harvard Business School. The third is Olaolu Sadiq, who is currently in secondary school. So their second child, Ademola, is married to Morenike Adewale Sadiq, a management consultant who earned both her bachelor's degree in chemical engineering and her master's degree in refinery design at the University of Manchester, from the University of Manchester. So Morenike is the daughter of Mr. Oluseyi and Dr. Mobola Johnson of Lagos, Nigeria. Our audience will agree that you have a successful and you're a happily married woman, very successful in both the professional and in the professional realm, as well as in the home front. So I have all the confidence to ask this question, which comes again from Dr. Chinwe Alaribe. She says, Prof, what word can you use to encourage young female scientists and female postgraduate students, especially here where the market is saturated with female leadership as well? So, how?
Okay. Can you hear me?
Yes, I can. So the question is, how do you encourage the female scientists in this regard? Haven't earned a lot of successful feats your own self.
Well, there is no manual. I wish I
Over
could.
to you, Prof.
Okay. Thank you so much for that question. I think I can, I wish I can say, here is the manual, or here's the lab manual that we can follow step one, A, B, C, D. There's no manual. I think you have to, there's a lot of, challenges involved in combining and balancing, both the professional and the home front. I would say that, I actually acknowledge my husband of 36 years and partner and friend who has encouraged me. Uh, my dad encouraged me. My husband sees my work as his. We work together as a partner, and I give God the glory. I thank God for the strength to be able to do what we're doing. I would not tell you that it's easy. I would not say that there is a manual or a pathway. But I think that working together and communication is important. We live in a world where, we have to play a major role, as you pointed out, in the family keep up. We play a major role. And, sometimes when people become successful and then they begin to, you think, oh, no, no, no. I think we have to be reasonable. We have to understand that, it's a partnership. It's a partnership. We communicate. We help as much as we can. We understand the limits that we have as well. If something doesn't work out, it's not the end of the world. But at least we continue to try. I would say, yes, we have to continually help with the family upkeep. That is, one of the key things that will make things work. We have to understand the limit to our own individual. But most importantly, we acknowledge the strength that God gives and how God allows you to be able to do what you're doing, and be humble as well. I hope that helps somebody.
Thank you very much, Prof. I think Rohan, the network has not been kind to him today. Uh, yeah, it's clear. Your response is absolutely clear, and I think we all appreciate that it's not easy doing science and combining your family, and you've just been successful. I remember 2 or 3 years ago when I first got in touch with you for the interview that we will do for you. That was one of the questions that I asked as well. Perhaps I'll go back to that and share it on our social media handles so that people benefit from that. I think, to be honest, you've spent over an hour talking to us, answering questions, and this is about 8 a.m. I don't know whether you've had your breakfast or not. We don't want to hold you so long. Um, so I think I would just like to thank you again on behalf of the entire team in Science Communication Hub Nigeria and all other people that are part of this community for supporting us, mentoring us, inspiring us for the last 3, 4 years. And hopefully, people are inspired by this talk. And I would like to also tell our audience that the award ceremony would be next Saturday. About would send out a call for it, where Professor Sadik and other sponsors of the awards will also be there to give you a brief remark. So, Prof, I would like to thank you again for being here, and I hope that you will continue to support us continue to inspire this community so that eventually we'll have more people like you to change Africa as a whole.
Thank you so much. I want to thank you for the hard work you're doing. Please continue to encourage the young ones. Science and life sciences and technology, engineering, the key to economic development. So please continue to encourage them. For those in the audience, please continue to focus on what it is that you're good at, identify your strength, and follow your dream, follow your path, and you will be successful. Have a blessed day, all of you.
Thank you so much. Bye bye,
Thank
Prof.
you. Bye. Bye.